October 16, 2025, from a silent polar orbit around Mars, China's Tianwen-1 spacecraft sent back data that no one was expecting. It wasn't an image, it wasn't a trajectory update, it was a spectrographic readout, wrapped in a time-stamped file that carried no official annotation. But inside that file was a thermal scan of interstellar object 3I Atlas.
So is it a cosmic coincidence, or is it the first whisper from something that is not from this world?
And what it showed was not just strange, it was terrifying. Within minutes of receiving it, Chinese mission controllers realized they had captured something fundamentally different. The object wasn't releasing heat randomly. It was pulsing, deliberately, rhythmic, timed, as if something inside was responding to its solar environment. And then, more anomalies emerged. Interior reflections, perfectly spaced cavities, cyanide bands, and possibly internal pressure. Was this natural? Was this even inert? Or had Earth just recorded a signal from something designed? Stay tuned, because what follows is China's full observational timeline, and why some of their top astrophysicists now believe there is something terrifying coming from inside the object. While most of Earth's telescopes were blind, overshadowed by the solar conjunction that left 3I Atlas hidden in the glare, China's Tianwen-1 had the one angle no one else could reach. From its high Martian orbit, Tianwen-1 maintained a stable 37-degree elongation angle from the Sun, just enough to continuously observe 3I Atlas, even during the peak of solar interference. That angle proved critical. It meant uninterrupted visibility, while Earth remained dark and silent. Between October 10 and October 16th, the orbiter dedicated 3 separate observational passes to the object. Each pass lasted just under 16 minutes, using a rotating set of near-infrared and microwave sensors. While the original plan was to observe Martian atmospheric shifts during solar maximum, the scientific payload was quickly redirected, quietly, by China's Deep Space Command team. They prioritized 3I Atlas, without fanfare, without press. The result? A complete heat map of the object's surface taken from 48 million kilometers away. What it revealed shocked analysts. The temperature across the shell wasn't even, as you'd expect from a comet under sunlight. It varied in pulses. Localized heat zones flickered to life and then faded. Not randomly, but in timed intervals, roughly every 4 minutes. And each time the object's leading hemisphere crossed into direct solar line of sight, the heat pulse shifted toward the center line. To thermal scientists, this didn't just resemble a rotating rock or a frozen nucleus shedding gas. It looked organized, as if the body was managing its own thermal profile, balancing internal zones, or worse, controlling heat intentionally. This wasn't just an orbital window, it was a window into behavior, and it was only the beginning. The thermal pulses weren't just brief, they were rhythmic. China's team at the National Space Science Center tracked the waveform signature of the heat flickers across all 3 Tianwen passes. When they stacked the results, the pattern was unmistakable, a sinusoidal thermal pulse every 243 seconds, sustained over all orbits. But unlike gas venting or dust eruptions, common in standard cometary physics, this thermal behavior showed consistency, not chaos. There were no spikes, no erratic temperature changes, just a steady rise and fall, peaking at 3 degrees Kelvin above ambient, then returning to baseline with mathematical symmetry. China's leading spectroscopist described it as internally modulated behavior.
Detected what may be the first microwave whisper from an interstellar object.
Meaning the object itself might be controlling the heat output from within. That suggestion alone raised serious implications. In nature, you don't see comets pulse with timed heat signatures. Radiation from the sun doesn't turn on and off like a metronome. These cycles had to come from something inside. The data was run against a library of known comet behaviors, none matched. Even hypervolatile comets with fast spin axes don't produce this kind of timed fluctuation. Nor does any known asteroid, trans-Neptunian body, or Kuiper belt object.
So, is it just another fascinating celestial phenomenon, or did the mothership just separate into a squadron of reconnaissance aircraft?
This was entirely new. China's engineers speculated whether internal cavities could be expanding and contracting, like heat exchangers or bladder systems. Others proposed standing wave resonance within the object's shell. Still others hesitated to even publish, worried the global response to what the heat data implied. Because thermal regulation, especially timed regulation, suggests one thing above all: intent. And in cosmic terms, that is a terrifying prospect. Tianwen-1's onboard radar was designed for Martian terrain mapping, but for 3I Atlas, its narrow-band interferometric system was repurposed to probe the object's structure. When radar pulses were directed toward the body during its third pass, analysts expected a simple, solid core bounce back, like scanning a rock. Instead, they received echo patterns that defied those expectations.
For nearly 11 minutes, radio receivers recorded a consistent, measurable signal, not random, not noise repeating at precise intervals. The signal's origin appears to coincide exactly with the path of 3I Atlas, which is now leaving the inner solar system.
The returning signal showed multiple delayed reflections, not random, not fuzzy, but structured, spaced at regular intervals with clear harmonic drop-offs between layers. This is what's known in materials science as a multi-layer cavity return, something you get when a radar pulse travels through air, then hits metal, then bounces again from a second surface inside. The echoes indicated not only that 3I Atlas was hollow, but that it may contain concentric inner surfaces, a shell within a shell. The first internal reflection came 0.12 milliseconds after the surface echo, the second at exactly 0.24 milliseconds. That timing corresponded perfectly with a hollow cavity of at least 600 meters deep, assuming an average propagation speed similar to vacuum or ultra-thin atmosphere. That's not how natural objects behave. Even loosely packed comet interiors scatter radar energy. But this, it was precise, layered, quiet. China's National Space Agency did not immediately release these radar findings, but leaked documents suggest the object's interior may consist of a central cavity, surrounded by curved barriers or compartments. Almost like engineered bulkheads, even the curvature of the echo bands implied internal symmetry. You don't get that from fractured stone, you get that from design. The hollow core was no longer theory, it was measured, and it opened a door no one expected. What if this object wasn't just passing through the solar system, but was designed to observe it from the inside out? After confirming the hollow structure, Chinese analysts turned to the most delicate measurement possible from orbit: Doppler shift variation across internal surfaces. It's a technique usually used for studying atmosphere, but in this case, Tianwen-1's long-range spectrometer picked up something far stranger. While the outer shell of 3I Atlas reflected frequencies at a stable redshift, the internal layers showed subtle variances. Specifically, the frequency return from the inner structure was offset by 2.4%. This may sound negligible, but in orbital mechanics that is massive. It suggests that the interior mass of 3I Atlas is rotating independently of the outer shell. In other words, the core is moving at a different speed than its own hull. That kind of motion has only ever been observed in one domain: engineered systems, gyroscopes, bearings, free-floating modules inside spacecraft. In nature, there's no known mechanism for an asteroid or comet to rotate independently within itself. In fact, gravitational cohesion should prevent it. But here, Doppler spectroscopy was telling a different story. The core wasn't just hollow, it was decoupled. Even more alarming, the axis of rotation appeared slightly tilted compared to the outer shell's spin, a misalignment of just 1.6 degrees. It's as if the inside was precessing, slowly shifting its orientation, while the shell remained inert. Chinese mission engineers described the data as unprecedented. Some speculated about natural causes, an object fragmented and then loosely fused together. But the alignment was too perfect, the inertia too smooth. So a terrifying possibility arose. The core is not passive, it's stabilized, and the only known reason for that is navigation. While radar and thermal data offered structural insight, it was the chemical signature that drew the most hushed reactions from China's inner scientific circles. Near-infrared spectrometry, typically used for identifying atmospheric gases on Mars, revealed an unexpected and deeply puzzling elemental pattern from 3I Atlas. Along its midsection, Chinese analysts detected concentrated bands of hydrogen cyanide and diatomic carbon. While trace cyanogen compounds have been found in comet tails before, the levels observed here were far too high, over 600% greater than what any natural outgassing model could explain. But it wasn't just the quantity that alarmed researchers, it was the symmetry. The cyanide compounds weren't drifting. They weren't spread irregularly like volatile plumes. They were locked into a narrow latitudinal band, forming a belt-like chemical trace around the object's midsection. It was as if the material was sealed within a segment of the hull and only released in localized zones. Natural comets do not create chemical belts. Their gas emissions are chaotic, triggered by solar heating or spontaneous fracturing. What Tianwen-1 detected was controlled, even deliberate. The implications were unsettling. One theory floated by Chinese researchers proposed that the object's outer shell might contain internal storage chambers, pockets of exotic molecules that were shielded until released at specific angles or distances from the sun. And hydrogen cyanide isn't just exotic, it's reactive. On Earth, it's a powerful compound used in chemical synthesis, signal flares, and even propulsion fuel. Some theorists in Beijing privately speculated whether these cyanide traces were residue from internal processes, perhaps a failed reaction or an active mechanism deep inside the core. Either way, this wasn't simply outgassing, it was containment, and that makes 3I Atlas more than an interstellar rock. It makes it a system. While radar and thermal imaging dominated the headlines, there was a smaller signal buried in Tianwen-1's magnetometer logs, one that didn't come from light, or gas, or heat. It came from vibration. During a 7-minute observational window on October 14th, the orbiter recorded magnetic oscillations that repeated with uncanny precision. Every 11.7 minutes, a patterned shift in the local magnetic field occurred. When graphed, it formed a nearly perfect sine wave. At first, scientists assumed it was local Martian interference. But then, as the pattern repeated across 3 separate orbits and aligned precisely with the direction of 3I Atlas, the theory shifted. The oscillations weren't environmental, they were acoustic in origin. But how can sound travel through space? It can't, not in the traditional sense. But inside a sealed body, acoustic standing waves can form. These are vibrations trapped within a solid or gas-filled chamber, bouncing between surfaces at regular intervals. Think of a bell ringing, but in vacuum-locked metal. Chinese scientists proposed that the object's hollow interior may be acting as a resonant chamber, amplifying some internal mechanical motion into low-frequency vibrational energy. And that energy, in turn, was subtly warping the magnetic field around it. This kind of behavior